Hi, everybody. Good afternoon. I hope you had a good lunch, and I hope you don't fall asleep. So what I'd like to do today is give you an update on what has been happening at AWS in the area of quantum computing recently. And I'd like to cover four main topics. First of all, what's new at Amazon Braket, followed by a quick interlude regarding the quantum enterprise journey, kind of like patterns that we have observed recently, followed by an introduction of our new offering that we have called Quantum Embark. And at the end, I would like to do a very, very brief flashing of some of the cool engagements we've done with customers with the Advanced Solutions Lab that I lead in professional services, leveraging the QEra neutral atom device. So what's new at Amazon Braket? I suspect that everybody knows, but maybe not everybody at all. What is Braket? It's actually a fully managed AWS service, like any of the services like S3 or EC2, that can help you accelerate your quantum computing research. On this service, you can build, test, run, and analyze your quantum data. What this means is that we have SDKs in place that allow you to write your quantum programs, your different routines. You can then test these on simulators, see if things are working properly, after which you can run them on the actual quantum backends, and then you can use the available tools to analyze your data and benchmark performance, for example. Right now, AWS houses hardware from 4 different vendors. On the left-hand side, you have 3 machines that can handle quantum circuits. We have currently 2 devices from IonQ. As you can see, we have Aria, the 25-qubit device, and more recently Forte, the 36-qubit device. We also have a superconducting device by Rigetti that will be online soon. It's the Anka 3 with 84 qubits. We have more recently added a device by IQM, the Garnet device with 20 qubits, also superconducting. And in addition to these 3 gate programmable systems, we also have a special purpose annealing machine based on neutral Rydberg atoms by QEra that currently has 256 qubits. This device cannot be programmed with a gate model at the moment, but it allows you to actually solve optimization problems that can be mapped onto what is known as the maximum independent set. So let me go over some of the current Braket features, and also a couple of new things we've added recently. When you download the SDK, you have local simulators, but as you might expect, we also have managed simulators in the cloud. We have a state vector simulator, a density matrix simulator, as well as a tensor network simulator. And these allow you to run up to 100 tasks concurrently. We also have embedded simulators. We have the ability to run hybrid jobs, and I summarize it as BYOS. This is not bring your own salad, but bring your own simulator that allows you to add your simulator, whatever you have developed, and run these in hybrid mode. Now, more recently, we announced also support for NVIDIA's Q2Q that allows you to leverage CPUs, QPUs, and also NVIDIA GPUs to run your workloads leveraging Braket hybrid jobs. And then finally, I want to emphasize also something that we introduced this year that we call Braket Direct. What is this? It is dedicated private access to the QPUs. So you can make a reservation and say, I would like to use a particular QPU for so many hours on this particular day. The advantage of doing this is that it will be just you on this device, so you can do as much as you want. But more importantly, you have the ability to connect with quantum specialists. So team members from my organization, the Advanced Solutions Lab, can work directly with you and help you set up your experiments such that you get the most out of the time that you have reserved. The other neat thing is that by doing this, you also have the ability to test certain capabilities that are not in general availability yet. So the goal is to give you the opportunity to experiment with the latest, greatest. So now let me switch gears and tell you a few observations that we had recently regarding what we call the quantum enterprise journey. When we look at the customers that we engaged with over the last couple of years, we found mainly 3 customer personas, and we also found mainly 3 main things that customers want to do. On one hand, they want to generate IP. They want to conduct basic science, experiment with quantum devices. But they also want to engage with the community And they also want to build a workforce. In other words, train internally folks in their companies to see what is possible with quantum devices today. Now, I want to go through each of those three independently and then dive a little bit deeper into the different personas that we observe and how we're actually helping our customers get the most out of quantum technologies. Now, what about generating IP? This is typically work that is done in conjunction with the Advanced Solutions Lab in ProServe. I'm just going to very briefly flash 4 publications with JP Chase, BMW, Goldman Sachs, and Fidelity. What we do is we do hand-in-hand research with our customers. We look at problems that they're interested in, and we analyze them, we run them on quantum devices, and basically the goal is to do scientific research, produce peer-reviewed publications, and generate IP. Now, customers also want to engage with the community. And as some of you might have seen, last night we announced the winners of the Airbus BMW Quantum Mobility Challenge. So what was this challenge? We had 5 tracks with over 100 submissions worldwide. This was all beautifully coordinated by the Quantum Insider. After a lot of debate, we choose 15 finalists that then basically got to leverage Amazon Braket for their experiments. And then the winners were announced yesterday at Q2B. Again, congratulations to all the winners that I'd like to show here. For the smart coating use case, a team from University of Southern California, logistics, 4 Colors Research, GenAI, Quandela. Quantum Solvers was the University of Hamburg. And for the golden app, which is basically a reverse challenge, bring a good problem to us that you think quantum can handle, was TU Delft. So again, congratulations to everybody that has won. Now, the third thing that customers want to do is build a workforce. And for this, I'd like to just go over again a little bit the concept of enterprise readiness. We have seen some patterns. And what we have seen is that we have 3 levels of enterprise readiness. We have quantum starters, quantum engaged, and quantum capable. At least this is what we call them internally. And now I'm going to go to each of these and explain roughly where they stand in their quantum journey. Quantum starters typically are companies where C-level mandates, hey, we've heard about quantum computing. Can somebody go look into this and make sure that we're not missing the boat? The alternative is that you have staff, there might be some researchers that have a physics background that might be very interested and that want to conduct research leveraging quantum technologies. The quantum engaged case is the next step. These are companies that have set some goals for the next 3 to 5 years, for example. They currently have small teams. They're doing some trials, experimenting with POCs, trying to understand really, what is the value that quantum technologies can bring us. And the third level are the quantum capable teams. They have dedicated teams, like, for example, JP Chase. They have developed a long-term strategy when it comes to quantum technologies, currently doing cutting-edge research, and also developing IP and producing papers, filing patents. Now, we have ways to address these 3 customer personas. For the quantum starters, we have Quantum Embark that I will introduce in the next slides. For the quantum engaged, you have Amazon Braket, and you can also leverage Braket Direct if you want to run some serious POCs. And for the quantum capable is the Advanced Solutions Lab that I lead, where you can do hand-in-hand research with us. And I want to emphasize that we're a bunch of scientists with different backgrounds, but our goal is to find applications for quantum devices, yet also think about how we can push the boundaries of what is possible today. With this, I'd like to introduce Quantum Embark. What is it? It's basically a quantum computing advisory program for our customers. And this quantum computing advisory program consists roughly, give or take, about a 12-week quantum readiness program, where you have no upfront commitments. So there's no subscriptions, no long-term commitments. The goal is just, hey, I want to know more about quantum, reach out to us, and then we can basically scope it out, see what you're interested in doing, and go from there. We have 3 modules for Quantum Embark. We have a use case discovery. Typically, what we do is we will meet with folks from the customer side. We will look at their business, look at their use cases, try to understand where quantum technologies might potentially bring value in the future, and then we deliver a nice white paper that can be used then, for example, to dictate strategy inside a company. The second module is training and enablement. The idea here is to have really classroom on-hands training such that you can bring folks from your company or your institution and have a deep immersive training on how to use Amazon Braket, how to build circuits, how to run these algorithms on actual hardware, etc. And finally, the third module is the deep dive, where we have a particular customer that comes with a very specific use case and says, let me pick a random example, portfolio optimization in finance, says, I want you to look at this with us in detail and help us assess how we can tackle this problem leveraging quantum technologies. Now, you don't have to go through 1, 2, 3. You can pick and choose. There will be companies, for example, that already have some basic quantum capabilities. They might want to go straight into a deep dive for a use case. But there's other companies that might just be curious to know, well, is this going to impact my business down the road or not? They might pick the first module. Or we might have, for example, some government agency that is interested in doing hands-on programming on quantum devices. They might just pick the second module. So it's up to you to choose which ones you actually want to use. What is the goal for us to develop Quantum Embark? The goal is very simple. We want actionable outcomes, and here comes the important thing, without the hype. I think it's fair to say there's a lot of hype in our industry, and we're trying to remain the voice of reason in the community. We want to make sure that we tell you things that can happen today, tomorrow, and in 10 years, but not that the timelines of these things get confabulated. And so the goal really is to understand if and when quantum technologies will impact your business, and also inform your business stakeholder with target use cases. In other words, give you a clear understanding of what is possible today, what will be possible in give or take 5 years, 10 years, or in the very distant future. Now, we recently launched a pilot, Quantum Embark engagement with Vanguard. And they wanted to do basically a deep dive. We looked at particular use cases in finance that could impact their business. We delivered a detailed report focused on financial applications. And now you might ask, well, potentially, what is the next step for this particular engagement? If they're so interested, we could do hands-on training for their workforce. Or they can engage with the Advanced Solutions Lab and basically look at a particular use case, dive deep, and develop IP, publish scientific papers, for example. Good. Now, in the last minutes that I have, I'd like to switch gears and tell you a little bit what the Advanced Solutions Lab has been up to in the recent months. And for this, I'm going to show you 4 projects that we have done, some of which are still ongoing, with our customers. And I decided to just focus on projects where we're leveraging QEra's neutral atom quantum device. So here you have 4 example projects that we did. On the left, you have 2 projects we've done with members from the BMW group. In our first project, we did what we call quantum-informed recursive optimization. This was looking at our optimization problem, in this case, the maximum independent set, using QEra's neutral atom device, but then running the device in a way that we keep track of correlations and use these correlations to decimate the problem, fix variables, and then reduce the problem complexity so that it's easier to solve. Together with the same team, we also wrote a second paper that you see on the tile second from the left, where we leveraged Bayesian optimization to design optimized schedules for these annealing machines. And this is a really cool paper because it shows you very nicely that by just putting a little bit of effort into designing the right schedules, you can get a lot of mileage out of these systems. Now, switching gears, we have an ongoing engagement with JPMorgan Chase at the moment. We've already put out 2 papers, one where we analyzed the hardness of the maximum independent set problem, something that is very dear to me, because if we're going to benchmark a device, we want to really understand, is this problem hard enough to tickle out any performance? And then more recently, we put out a paper related to problem decomposition, where we show how you can take a portfolio optimization problem and then basically break it down in components that are more manageable for a quantum device. These papers are all currently on archive. You can go check them out. And stay tuned, because there's a few more coming, hopefully not before the end of this year. And then the last one that I want to mention to you is very dear to me. This was with the Australian Red Cross, also known as Lifeblood, where we did a POC on looking at nurse rostering, leveraging a neutral atom quantum device. Now, I want to dive a little bit deeper into this one for the following reason. Number one, of course, as you might imagine, it was like 2 nurses and 3 shifts, given the currently available hardware. But the nice thing that we did also is that we looked at this from a different angle with the researchers on the team, and we developed a constrained programming solution for nurse rostering that they can use at scale. So not only did we teach them how to leverage neutral atom devices going forward, but we also delivered to them a solution that can run in production. Fun fact, if you run state-of-the-art optimization solutions on the rostering problem, the cost per blood donation goes down by about 47%. So long story short, looking at problems with new alternative technologies, be it quantum, be it something different, can unlock a lot of value for your business. And this is one of the important things that we focus on in the Advanced Solutions Lab. So if you're interested in doing some interesting, cool science, come build with us. And with this, I'd like to come to a conclusion. If you want, you can take the Amazon Bracket Digital course. It's an online course. You get a little digital badge you can pop on LinkedIn that says, I know what a shot is and what a circuit is. You can get started with Quantum Embark if you want us to look at your business in more detail. And then finally, check out our research blogs, where we usually put up the latest, greatest of the work that we've done in a way that is easy to digest for everybody and it's not deeply technical. And with this, thank you for your attention.
Thanks, Helmut. So we have one question that came in, and it says, based on your experience of the Fortune 2000 and similar companies, approximately what percentage fall in levels 1, 2, and 3 versus not quantum curious at all?
That is a very hard question to answer because I have a very limited data set. If I talk about 20 companies, I'm looking at 1% of 2,000. What I can tell you is that there's a bunch of quantum pioneers, companies that have made big investments, but they're the smallest fraction. I would say the second tier, companies that have heard about it, want to learn a bit more, have maybe somebody in-house experiment, are also about roughly the same fraction. But the big low-hanging fruit are really companies that just have read stuff in the press and really want us to assess what value quantum technologies will bring. And so since we launched Embark, we've had a lot of requests, a lot of interest from different large AWS customers that really want us to go and look at those. So I would say, fractionally speaking, the big bulk part is really companies that have not embarked yet, are yet to invest, followed by 2 similarly sized chunks that are much smaller, which are people that are actually already engaging with quantum technologies.
Great. All right. Thank you, Helmut. Let's give him a hand. Thanks so much.